So how could we go about choosing a stratified random sample? What's a stratified random sample again? We split them into groups. So yesterday we created strata, right? We had strata that were the rows, and then we did it again where our strata were the columns. What should we use as strata in this situation? What'd you say? So I want to get a sample of 36 people. I want to know how to pick out the 36 people that we're going to choose. Split them in half. How? Like, tell me how. Because again, we're supposed to make a stratified random sample, so I want to know what are the strata that we're using to take our whole population and divide them up so that we can pick some from each of those groups. Yes. We could use reading rooms as strata if we wanted. If we use reading rooms as strata, what happens to these people? Because they're part of our population too, right? So what do we do with them? We could have that as being a room. So we could have our 100 reading rooms, and then we could have the 18 members being their own reading room. How are we going to use stratified random sampling if we have those 100 reading rooms to pick out just 36 people? I do like the idea of using reading rooms as the strata, but how do I use that then to pick out 36 people? Can I take some from each of my strata if I use the reading rooms as the strata? I love that plan. That would work perfectly down here for part B. That would be cluster sampling. So cluster sampling is similar in idea in that we divide our population into groups, but for cluster sampling, we're dividing them up based on locations. So those reading rooms would make great clusters.
What if you took groups of 10 rooms and take a number of those?
So groups like, so have my strata be like 10 rooms is this strata, 10 rooms, so I'd have 10 groups then, plus these guys, right? So I'd end up with 11 strata total. How do I use that to get 36 people? I love these ideas. These are the kinds of things that you guys are going to be sitting down trying to figure out as you're answering these types of questions. So let's work through it. Remember, when we're doing stratified random sampling, we want to divide up our population based on some characteristic that they all have in common. So what room they've been placed in would be a characteristic that they all have in common. What else do they have in common, not necessarily with the whole big population, but with some other people that are here? What would be another characteristic?
Some of them are exam readers, table readers, and other leadership.
There we go. So we have, each reading room consists of 16 exam readers, 2 table leaders. So we have 1,600 total exam readers, right? Because 100 rooms, 16 people in each of those rooms are our exam readers. We could have 200 table leaders total who have a different job. They have a different characteristic here than the people that are just doing the reading. And then we've got these 18 members of the other leadership that are working together. So they have a different job. I do think that those are probably some characteristics that I would use for stratified random sampling. Cluster sampling, again, I'm looking at, are they grouped together already nicely for me? Are they in the same general location? Because for cluster sampling, I want to go to one location and get a whole bunch of data. And then I want to go to another randomly selected location and get a whole bunch of data there. Stratified sampling isn't necessarily convenient, but I want to make sure that I get the opinions of all the important groups that we have. So personally, I think the strata here would be the exam readers, the table readers, and then those 18 members of other leadership that are all in a room together. So if I have those 3 strata, how could I get a sample of 36 using those 3 strata? I could do 12 of each, right? Or since there's a lot more exam readers than there are table leaders or this other leadership group, I could do it proportionally. Let's see, we have 1,800 plus 18. So what, 18, 18, figure out what percentage of those are the table readers, what percentage of those are the leaders, what percentage are this other. We could divide it out that way. All right, so my stratified random sampling, here's the model answer that I had. Said use the employer's role as strata, label all of the exam readers from 1 to n, use a random number generator to select 12 people from 1 to n. These individuals are selected for the sample. Repeat the process to select table leaders and 12 members of the other leadership group. So picking 12 from each group is what I had in my model answer. When you are being asked to describe how to do a random sample, you have to clearly explain what are the strata that you're using. So in this place, we're using their role as the strata, and you have to explain how you're going to pick out. You can't just say pick 12 people out of each group. You have to describe in detail how you would go about picking out that group of 12. Because what they're looking for in that part of the question is, do you understand how important it is that they are randomly selected there? So what you have to show is that you understand that you're either going to use a random number generator. You can't just say, I'll use a random number generator to pick out 12, because they're like, okay, you got 12 numbers. How does that help you pick out the people? So you have to say that you have assigned each of the people a number, and then you'll use your random number generator from 1 to however many people there are in that group. That's why I said 1 to n. I could have said 1 to 1,600, and then in the other groups, 1 to 200 and 1 to 18, choosing 12 members of each group. If you're going to do the same process for the other groups, you actually have to very explicitly say that. I would repeat this process exactly for this group and for this group, but you have to have it laid out like you're trying to explain to somebody else how to enact your plan. All right, so cluster sampling. Cluster sampling, again, is based on location. Easy access. What could we use as our clusters? We could use the rooms as our clusters. They're going to be in the same location, and I'm going to get differing opinions in those different rooms. How many people are in each room? 18 total, right? Because we've got 16 exam readers, 2 table leaders. How many rooms total would we have then? 101 rooms, right? Because we have 100 reading rooms, and then we've got this other leadership room. How would I then take the 18 people that are in each of those different rooms, using my rooms as clusters, and get a sample of 36? How many rooms would I need to randomly select to get 36? There's 18 people in a room. What'd you say? Yeah, how many rooms would I need to select? 2, because I need 36 people for my total, or 36 people total. How would we pick out those rooms? Number the rooms 1 through 101. Yep, and then use a random number generator to select 2 of those numbers. So let the rooms be the clusters. There's 18 people in each room. Label the rooms from 1 to 101. Randomly select 2 distinct numbers from 1 to 101. All the people in those rooms are selected for the sample. So there's 100 reading rooms, and then there's this other room. So there's 1 more room on top of that. If we do it this way, does everybody in the population have an equal chance of being selected for the sample? Yes. Will everybody be selected for the sample? It's considered to be unbiased or a good sample if everybody has the same chance of being picked. That doesn't mean that we're going to end up with a perfect sample. We could still end up with a biased sample, but we've used a method that is more likely to give us an unbiased sample. Oh, I still got it up there, it's just up at the top. What would be a benefit of using stratified random sampling? In this particular situation, what would be a benefit of going with stratified random sampling?
I think that it would make sure that every kind of employee gets recognition and they get a say.
Yes, love it. We're going to ensure that people from every role or every type of employee is going to be part of the sample. This is going to give us a more precise estimate of the variable of interest, because we're making sure that we're not systematically leaving any group out. It's not like we're not going to talk to any people that are table readers, but we're also making sure that we get the opinions of table leaders and we're getting the opinions of that other leadership group. Why would cluster sampling possibly be beneficial for us? Yes.
I feel like it would vary less. The difference in the answer would be less if it was one from each.
So we're going to do cluster sampling in a minute. I want you to kind of keep that in mind because we'll see what happens to our distribution. We can't necessarily answer that yet because we haven't done a cluster sample. I like that thought though. There's definitely one huge benefit that I've seen time and time again for why this particular method gets chosen. If we did cluster sampling the way we described here, how many places do I have to walk to get my sample? I have to go to 2 rooms. Is it going to take me very long to get all the data that I need? Would it cost me very much money in terms of time is money? If I'm getting paid by the hour, is it going to cost very much money to do that? No, takes less time, takes less effort. I get a lot of information really quickly. Cluster samples are fast and easy. It's not necessary in this one to label every person, so I don't have to know what the entire population is if I'm using cluster sampling. I just need to know every room. All the employees that I need to talk to in my sample are in just 2 rooms. So cluster sampling benefit is definitely that it's fast and easy. Stratified sampling is pretty precise in terms of which sampling method is going to get me the closest to the true mean, the true average. Right. Do you guys remember what we did yesterday when we were surveying the Taylor Swift fans? So same kind of thing. Go over and flip to page 11 when you're done getting some of this down. I want you guys to pull a simple random sample first, just like we did yesterday when we started. How do we do a simple random sample of these fans? Number them. Number them what? 1 through 50. And then I want a random sample of 10. So how do I do that? Random number generator going from 1 to 50. Pick out 10 random numbers. I want you to do it exactly like we did yesterday. So on page 11, and then mark the seats on there that get chosen. Label your people 1 to 50. So you need to use a random, yeah, right now you just label them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 50. However you choose to go about numbering them. And then you'll go to just hop on Google on your phone, random number generator. And you'll have it generate 10 numbers, so you'll have to do it several times. You want to make sure that it goes all the way up to 50 though, it'll let you set the upper bound. I want you to pick out a random sample just like we did yesterday. All right. So you're going to need your phone for this. You have to label these guys from 1 to 50, whether you go like this or whether you go like this, doesn't really matter. You just have to give everybody a number so that when you use that random number generator, you'll just go to Google, type in random number generator, and it should pop up. Okay. So it lets you set the max, yep, fix that to 50, label these guys, and then you want to generate 10 unique numbers, which means if it gives you a repeat, you just ignore it and move on.
What do I have to do?
So you're going to label them 1 through 50, and then you're going to use your random number generator to select 10 of those seats, just like we did yesterday. That was a quick second. So after you get them labeled, you want to make sure that you have 10 of those seats selected, whether you darken them in, whether you circle them, somehow indicate which seats got chosen using your random number generator. So for the next one, and if you're not done picking out your first sample yet, that's okay, but I'm going to go ahead and give directions for method number 2 for those of you that are there. To make it easier to distribute the surveys, the promoter decides to pick just one row and sample every fan in that row. So I want you to use that method to select a sample of 10 fans. How are you going to decide which row? Do 1 through 5 in your random number generator and use that to select your row, and then I want you guys to mark the row that was chosen. So whatever random number it came up with, you're going to mark all 10 seats in that row. So use your random number generator to pick one of the rows, and then you're going to mark all 10 seats in that row. This would be an example of cluster sampling. They're all in the same general location. They're all in the same row together. So I can go down the aisle, I can stop at that row, and I can pass the surveys down that row. They're in the same location as each other. Remember, we're asking Taylor Swift fans how much they enjoyed this show. Do you think that this method, picking one row and going with all 10 people in that row, is going to give us good estimates? Why not? Yeah, so like if there's a huge difference of opinion between, say, the first row and the fifth row, I'm not going to get first row people's opinions and fifth row people's opinions. Did you have a thought?
Well, yeah, because I said every seat in that row can have a different perspective on the stage.
Absolutely. Every seat in that row is going to have a different perspective on the stage. So I don't think that my sample's worthless, but I do think it's going to have some problems. Think about this from the fans' perspective. If you paid for front row seats, how do you think those people overall are going to rate their concert-going experience? Probably pretty high, right? Fifth row back, they're probably not saying it was a horrible show, but are they going to be as high as, say, somebody in the first or second row? Probably not. So I would say the front rows are probably going to be overestimates. Again, I'm just generalizing here, but the front rows are probably going to be overestimates. Back rows are probably going to be underestimates. So for this one, you want to use a random number generator, pick something 1 through 5, and then you're going to go with that entire row, all 10 seats across that row. All right, we're going to come back to this one here in a little bit. Third one. Taylor's manager thinks it's important to sample fans that have different views of the stage. This is something that Akeem brought up a moment ago. So he's going to sample every 8th fan. So first we need to find out the starting fan. How many fans do we have total in these seats? 50. So use your random number generator to pick out one person. That'll be your starting person. 1 through 50. Pick out that first person. 49, all right, so you're gonna start with this one down here.
I got 15.
You got 50?
15.
15.
So, then we just count.
Yep, so you'll mark the person that you got. That'll be your first person that gets the survey. And then you're gonna go, starting from that person, then move over to the other seats. 1, 2, 3, 4, 5, 6, 7, 8. Mark that person. Then 1, 2, 3, 4, 5, 6, 7, 8. Mark that person. If you run to the end, you're just gonna loop right back to the beginning as you're counting. Yep, so for the person that got 49 as their starting number, 49 would be here, but then it would be 1, 2, 3, 4, 5, 6, 7, 8, and I pick this person.
Wait, are we going to the side or?
You decide whether you're going side to side or up and down, but stay consistent with it. Whether you're going across the row or up and down, start with your first seat and then mark every 8th seat after that. Until you have a sample of 10. Good question. You need to end up with 10 total seats. So you're just going to loop back around to the beginning as many times as you need to get 10 total seats. Yeah, so for this one, you want your random number generator to go up to 5 because you're going to pick a whole row. Okay, so it gave you 5, so you're going to pick all of those seats. No, all of them. Mark all of them. That entire row gets your surveys.
And that's it?
And that's it.
Can you explain it more, like, I guess, why, like, how?
So a cluster sample. With cluster sampling, you're looking at people that are in the same location as each other. So let me give a slightly different example. Maybe this will help make sense. If I wanted to sample, say, Pike Middle School students, and I know that everybody on this particular day is riding the bus home, I don't have time to go and talk to every single person. I don't even have time to go talk to all the buses. But I could use a random number generator, put all the bus numbers in there, and use that to pick out 3 buses. I have time to go to 3 buses, and I go to the bus and I ask everybody on that bus. And then I go to my second bus and I ask everybody on that bus. And then I go to the third one and I get everybody's opinion. I'm going to end up with a lot of information without having to do a lot of running around because I picked people that are in close location to each other. Does that make sense? In this case, we're using the row as our location. Because I mean, when you think about being in a theater, if you know, you can easily walk up and down the aisles, but like getting to the center, you gotta wind around other people. So it would be easy if I went to the aisle and just said, hey, hand this down to everybody, because I want their opinion. Does that make sense? All right. Of these 3 methods that we've talked about, simple random sample, cluster sample, this one right here is called a systematic random sample. Why do you think this one gets called systematic? Yeah, we had a system to how we were picking them, right? We decided ahead of time that we were going to pick every 8th seat. We randomly chose where to start. That's why I get to call it a random sample. I didn't choose where I'm starting. I randomly selected where I was starting from. And then we counted over and we used our system to find all of the people that were going to be involved. Of these 3 methods, simple random sampling, cluster random sampling, systematic random sampling, which one do you think of these 3 is going to give us the best, most accurate results? My guess would be systematic. We'll have to see once we get it up on the board in the back. This one is always going to make sure that I get people that are spread out throughout that theater. Cluster random sampling, I'm not getting people that are spread out in all the different rows and all the different columns. So ideally, since I've got people from all over the theater here, this one should be more representative of my population. All right, do you remember yesterday how we actually calculated the enjoyment level? We're going to do the exact same thing today. So after you've picked out your 10 seats using all 3 of these different methods, you're going to flip it over to page 12. It has the actual enjoyment rating for the people that attended. You want to find their scores for the seats that you selected for method 1. Add up those 10 scores and divide by 10. Then do the same thing for your custom random sampling. Find the row that you randomly picked, add up all 10 of the numbers that are in that same row, and then divide by 10, and then do the same thing for your systematic random sampling. Yep, absolutely. Alright, so green stickers for your simple random sample, the ones you did first. Posters today are in the back on the whiteboard. Simple random samples, the one farthest to the left. Once you have your first average, using your simple random sample, so the first sample that you collected, then I want you to go to the back. Farthest to the left, it says SRS, method number 1. You're going to put your dot on there. In the back, farthest to the left one is the simple random sample. Yeah, those are just the seat numbers. You want to add up their enjoyment level. So how did they rate the show? Those are the numbers that you're adding up that go with the seats that you selected. You'll add those up and then divide by 10. This is your dot for method 2. So again, once you've got your first one, your simple random sample, then move on to method number 2, your cluster random sampling. That'll be a yellow sticker. I'm so sorry. Okay, so that's for your simple random sample. That's this one. Yeah, this one. Yellow is for your cluster random sample. think there's still.
The other one is blue.
Yes. Alright, method number 3. When we did our systematic random sampling, that one gets a blue dot. And that goes on the farthest right. Yes, divide by 10 because you had 10 numbers. Sample 2, you'll divide by 10 because you still had 10 seeds.
Oh, you're
You do want to get these dot plots sketched into your notes, so you might want to turn around in your seat and start sketching out what we've got so far. You want to get those in those 3 spots in your notes there. So I'm curious, I know some people are still getting some dots up. What do you notice about these 3 methods? If we compare what we did today to what we did yesterday, what do you think was the overall best method for this? Stratify by row. Of the 3 that we did today, do you feel like we could pick out a best? Like a worst, better, best? SRS, you like as the best? Is this one bias? Yeah, what does bias mean again? Yeah, we didn't do a really good job of getting close to the real mean. This one is kind of, the true mean is lower than where I would probably put the center. I would probably estimate the center to be more like 80 or 81 based on our distribution, but the true mean was over here at 78. What about cluster sampling? Is that one biased? When you think about the center of that data? I've got 1, 2, 3, 4, 5, 6, 7, 8 dots here. 1, 2, 3, 4, 5, 6, 7 dots on the other side of it. Is it pretty equally balanced on either side? So what's the biggest problem with this one? It's really spread out. This one has really high variability, high standard deviation. High variability, but low bias. Of the three, I think this one probably has the lowest bias. This one, 1, 2, 3, 4, 5, 6, 7, 8 on this side, 1, 2, 3, 4, 5, 6, 7 on the other side. But does that look like it's probably where the center actually is? No, I probably push the mean, the average a little bit higher, but I'd say this one probably has lower bias than our simple random sample. It did a better job of helping me find the true middle, but it's not as good as what we did yesterday when we did stratified by row. Why do you think, if stratifying is such a good method to use, why don't we just use that one all the time? What would be a drawback to using stratified all the time? Yeah, we have to have every single member of the population. We have to be able to number them all. Same kind of problem that I have simple random sampling. What else could be a problem with using stratified random sampling? What'd you say?
Takes a lot of time.
Takes a lot of time. Here's another problem. Do you guys remember when we started class and we were doing the check your understanding and it asked how do you use stratified random sampling to pick a sample? And a lot of people were struggling with what should I choose as the strata here? What's the important characteristic that I would want to make sure to pay attention to that I'm going to use to divide up my whole population? Sometimes it's really hard to figure out what would the appropriate strata be. Can anybody think about how we might have improved our cluster sampling? Still use cluster sampling, but where we might have done a better job with less variability. Yeah, maybe let every column be a cluster. Then I would need how many columns to get my sample of 10? I would need 2. So I would say a better approach to cluster sampling here would be to use columns. Each cluster would be heterogeneous. It's going to be from like the same position facing the stage from each of those different rows. We probably would have gotten a better idea using it that way. All right. Again, reminder on the homework, it's not due until Thursday. We're going to talk some more about bias tomorrow. We're going to do the check your understanding to start off with. And then we are going to talk about different types of bias, things that we need to be careful of.